The Army is already flying a new generation of helicopters about twice as fast as a 150 miles per hour Black Hawk and twice as far, breaking new tactical and strategic ground in preparation for warfare in the 2030s with unprecedented agility, maneuverability, weapons, and targeting technology. The now accelerated Future Long-Range Assault Aircraft program seeks to expand beyond previous technological boundaries and surge into a new era of aerial warfare capability to include unprecedented speed, fuel-efficient engines, smoke and fog-penetrating sensors, long-range high-fidelity infrared targeting systems, autonomous flight capability, AI-enabled computing, and a new generation of weapons. Upon initial examination, several immediate and widely discussed attributes are range and speed. The new FLRAA aircraft, according to both Sikorsky, Boeing, and Bell developers, can go twice as fast and twice as far as an existing Black Hawk. This means many things, such as speeds as fast as 300 knots and a combat radius close to 500 kilometers or more. Performance parameters expected to change helicopter air war for decades into the future. In a discussion about FLRAA last year, Brig General Walter Ruggin, director of the FEL cross-functional team, told Warrior that some of the technical breakthroughs with the new helicopter bring substantial new attack capabilities. We want the ability to operate the aircraft, conduct near-peer air assaults, and show up in places where the enemy does not expect us, Ruggin said in his interview with Warrior. One key element among the many innovations likely to inspire much focus is just how can these kinds of massive speed increases be achieved, with fuel efficiency and engine power sufficient to double ranges. This tactical reality completely changes the warfare equation when it comes to an ability to close with an enemy by delivering infantry soldiers, supplies, ammunition, or life-saving medical support. Both Bell and Sikorsky Boeing designs are considered compound configurations engineered with an intent to engineer a new platform able to both hover and maneuver like a helicopter, yet also achieve airplane-like range and speed. To accomplish this, Bell's V-280 Valor relies upon what developers call a new generation of Osprey-like tilt-rotor technology, which rotates dual rotors from a horizontal to vertical position depending upon mode. And Lockheed Sikorsky's Defiant X brings coaxial rotor system technology to new level. If you think of what a Black Hawk does when inbound to an LZ, then picture a 2030 contested operational environment. We will be flying twice as far and twice as fast, but they still have to be very maneuverable in and around the objective area, Jay Macklin, Sikorsky Business Development Director, Future Vertical Lift, told Warrior in an interview. What will this kind of increased combat functionality mean for modern warfare maneuver tactics and combined arms maneuver? Perhaps the angle of descent for a high-speed air assault raid can be much steeper. Perhaps hover positions can quickly shift positions as needed with short bursts of acceleration. Added maneuverability can help the aircraft elude incoming enemy fire and speed up low-altitude fast operations intended to achieve a specific combat effect while minimizing risk. More lethal, semi-autonomous, lightly stealthy, and twice the speed and range of a Black Hawk helicopter were just a few of the terms used to describe the Army's emerging future long-range assault aircraft, a now underway developmental effort slated to deploy by 2030. Calling it a future Black Hawk would both be correct and reductive, as the new aircraft will assume all of the utility helicopter missions, such as infantry transport, medevac, cargo delivery, and some reconnaissance. The new FLRAA will likely take on an even broader mission scope given that it is being architected for warfare in the 2030s and beyond. Case in point, an Army report described the new aircraft as something which will augment and not necessarily replace the Black Hawk. This medium lift, tactical assault, and medical evacuation capability will augment the Army's H-60 Black Hawk utility helicopter fleet to provide combat aviation brigades with long-range, high-speed options that are survivable in contested environments, a report from PA Aviation wrote a few months ago. Two aircrafts are now flying, one from Bell Helicopter Building, the V-280 Valor, and another Sikorsky Boeing team called the SB-1 Defiant. For the Army's FLRAA competition, Sikorsky and Boeing are offering the Defiant X based on the SB-1 prototype. The V-280 is engineered to be a next-generation tilt-rotor compound configuration, and the other is built with counter-rotating coaxial rotor blades and a back-end thrust propeller to achieve massive new amounts of speed and in-flight stability. Due to welcome, yet unanticipated progress, the FLRAA program has been accelerated by as many as 4 years, Brig General Walter Ruggin, the FVL cross-functional team, explained to Warrior in an interview last year. A key element of the acceleration is what Ruggin called an ability to upgrade at the speed of technology. This means that software and hardware configurations are being engineered to accommodate new weapons, sensors, computer systems, and engine technologies. The FLRAA has been surging forward following a multi-year science and technology development program called the Joint Multi-Role Technology Demonstrator Program. This means that, when viewed with the total mind to its requirements and new technological capabilities, the FLRAA may be destined to be much more than a Black Hawk. Developers told me years ago during the early S&T phase in 2011 that the intent for the new aircraft was not so much to build something based on the best available technologies, but rather architect something technically upgradable so as to operate successfully in the 2030s and beyond. This amounts to a technological configuration and sophistication sufficient to embrace a new sphere of missions beyond those intended for even the cutting-edge, upgraded Black Hawk M helicopter. We will have to be synchronized and integrated across a network and continue to evolve as things change in the 2030s. Heather McBrien, Boeing Sales and Marketing Director, Future Vertical Lift, told Warrior in an interview. A Black Hawk is reported to be able to hit speeds up to 150 miles per hour. Therefore, something twice as fast would be quite fast. While the exact speed of the Defiant X is not available, likely for security reasons, Bell reports his V-280 can hit speeds of 280 knots. The Defiant's predecessor, called SB-1 Defiant, is reported by Sikorsky developers to have reached speeds greater than 230 knots, adding that innovators continue to push the envelope beyond that. With the Defiant X builds upon Sikorsky's history of developing coaxial rotor blades to break new ground with its X2 technology demonstrator in 2010 by hitting 250 knots. Bell developers tell the National Interest that their V-280 has at 305 knots. X2 technology demonstrators set new records by flying more than 250 knots in 2010. Sikorsky's S-97 Raider helicopter in 2019 hit 207 knots. Sikorsky tells me they continue to expand the envelope as they prepare the Raider X prototype, a scaled version of the S-97 for the future attack reconnaissance aircraft. Fairer competition. It makes sense that new ULAD helicopters delivering infantry under heavy enemy fire in 2030 will need new levels of speed, maneuverability, and agility to succeed in an entirely new sphere of high-speed combat intensity, such as the premise of the FLRAA. The now in development Black Hawk-like aircraft for the 2030s intended to heavily impact, if not change, the maneuverability paradigm for utility helicopters moving into the future. Air assault raids, for example, will likely be of an entirely different character in 10 years, something which continues to inform the developmental trajectory of two competing aircraft. Bell's V-280 Valor, Sikorsky Boeing's Defiant X, many of the now airborne innovations necessary to achieve previously unimagined speeds and maneuverability are the result of years of innovation and technological experimentation. For example, Sikorsky Boeing engineers, builders, and weapons developers of the Defiant X have found a way to massively decrease or even remove what's called retreating blade stall by building rigid, counter-rotating rotor blades. The rigid rotor blades are engineered to mitigate pockets of instability in the air called blade stall, which could otherwise destabilize flight trajectory, adding new dimensions of agility such that the aircraft can more quickly arrive at a combat objective, stop, unload infantry, and then get out. We have done a significant amount of ground system testing and wind tunnel testing. We understand that maneuverability and agility are crucial to mission success as well as survivability on the battlefield. Jay Macklin, Sikorsky Business Development Director, Future Vertical Lift, told Warrior in an interview. Macklin further elaborated upon some of the technical innovations by explaining how a coaxial rotor system spins its upper and lower blades in opposite directions such that there is not a retreating side, creating a flight imbalance. The retreating blade side is referred to in the Lockheed Sikorsky Boeing paper as a reverse velocity region, which cannot produce lift, especially at higher speeds. Offsetting this potential instability, therefore, it can help enable and sustain much higher speeds without compromising or losing flight stability. Part of these new approaches to speed and maneuverability include a focus on yet another element of the Army's sought-after requirements for the aircraft: an ability to operate in much more difficult high-hot conditions, meaning 95 degrees Fahrenheit and 6,000 feet, where thinner air can challenge helicopter operations. Yet another element of technological focus, something fundamental to speed, maneuverability, and overall operational effectiveness, is the need to achieve and sustain lift. Sikorsky Boeing data on the Defiant X says that their aircraft can handle additional weight without having to grow the rotor diameter or the engine size, so any additional equipment, survivability features, payload including external lift, can be handled without a significant and costly redesign of key dynamic components. The Defiant X can sling load a 155mm howitzer mobile artillery cannon,